Alright, we got MPLS. The labels got distributed using LDP. Using the label, packets are getting forwarded, and this label way of switching packets makes the communication faster because you don't need to look into the layer 3 header of every packet. So layer 3 lookup is completely avoided in both the packet as well as on the router. On the router, we don't look into layer 3 routing engine because we have switch. On the packet, we don't look into layer 3 header because we have MPLS. And have you done any lab on MPLS? Basic MPLS? Okay.
I've done a lot in that you post.
You saw that we can distribute the label and enable MPLS for each network. The labels are getting distributed, and the labels are being used in order to forward the traffic. Even on the set table, you might have seen the labels when I do in the lab. And now we are going to see a layer 3 VPN that can be achieved between the PE routers of the provider network with the help of BGP and the MPLS. Without BGP, it is not possible. You cannot use any other routing protocol other than BGP. Let me draw you an old diagram which we usually use for BGP learning. You see, we got 3 autonomous systems and we got some provider routers. This is provider edge, this is another provider edge, and there are a lot of provider only routers. There are many routers and they are connected like this. I'm just doing random connection. So we got connections like this, and there's a customer on the left and the right. Let's say it's the same customer having 2 offices. One is on the left, another one is in the right of the ISP. Now, customer advertises the route from site A to site B. He advertises the route. Likewise, site B advertises the route to site A. We learned in the BGP class, you need to have full mesh to have site A routes to appear in site B's routing table. Likewise, to have site B's route in site A, we need to have full mesh. Do you remember that?
Yes.
Now, you need to have full mesh if you can have a VPN between these 2 routers. So we are going to form a VPN between these 2 so that you don't need to enable BGP anywhere here. You can totally avoid BGP. That's a big advantage of putting this VPN. Because BGP is a TCP based protocol, all the routes that are learned from here can be delivered directly to this one with label encapsulation. Listen carefully. I'm going to put the label to reach from alpha to beta. But inside, it is this as the original source and this as the original destination. When the packet comes here, alpha assigns the label of beta and packet goes like this to reach beta.
Okay.
and where it gets decapsulated and whatever that was sent from source is delivered here. So what we learn from here, we no need to run BGP on any of this inside provider router. No BGP is needed here. Just you need to have TE1 to TE2 reachability, for which I'll be using OSPF or ISIS. Using the reachability, I'm going to negotiate a VPN tunnel. I'm going to negotiate a VPN tunnel. Via the tunnel, for all the networks that are learned from site B, a label will be advertised. And that label will be learned here. And for local transportation within the provider, the label given by the next hop will be used, which we saw in the previous lab. For local communication between TE1 and TE2, to move the packet, it will be using the label that is provided by the next upstream router. Whereas for the packet to go from alpha to beta, and beta to alpha, there will be two labels involved. One, the label to identify the beta when the packet is here, and in order to go to beta, the label to reach this PE. Two layers of MPLS. When you capture a packet here, let's say if I capture a packet here, I will be seeing two labels. The top label is for local transportation within the ISP between provider. The bottom label is for identifying the tunnel endpoint customer. So how do I know? How the router knows that this is the top label, this is the bottom label? Answer. I told you just now that there will be two layers of MPLS. The top label is for moving the traffic within the ISP. The bottom label is to identify the customer or the tunnel endpoint. How do you know which label is bottom and which label is top?
How do I know which label is top and which label is bottom?
Yeah, I just said there will be two layers of MPLS when we have the
I'm not sure. Yeah, I'm
one
not sure
label,
how to identify.
one MPLS. Okay, one MPLS layer is what called as transport layer, and the label is called transport label. And the other one, which is to identify the customer in the tunnel endpoint, which is the bottom label called service label. Service label is the label that identifies the customer on the other end of the tunnel. Transport label is the label that moves the packet from this PE to that PE within the ISP. Now, how do I know which layer of MPLS is top and which one is bottom? If you see the bottom of a bit on, I told you on the other day, the size of the size of MPLS is, the size of MPLS is 32 bit.
Yes.
Do you remember? In which there is a bit called bottom of a stack bit. If that bit is on, If the bit is 1, which means that's the last layer of MPLS. If the bit is off, then it is called as transport layer.
Oh, okay.
Top transport. Transport layer label will have 0 in the bottom of a stack bit. Service label will have 1 in the bottom of a
All right.
stack bit.
Can I have a question?
Alright. Yeah, I want
Okay.
questions. Yes, please.
But do you have to make any special provision or any special command to say this is going to be the transport or this is going to be the service label? How does it know which one to be?
You see, the label that is coming through the tunnel, which means the label that is being distributed using BGP community is a
Okay.
service label. And the label which is simply distributed to LDP is transfer label.
Okay.
We are not going to do any additional command configuration for this. We are not going to do that. We are just going to do MPLS layer 3 VPN, all those things are taken care. Any other
No.
question? Okay. So in order to have VPN, we need a protocol that can form neighbor with a remote PE. The only protocol that can do is BGP. Not only that, only BGP can distribute the customer routes to the remote PE using extended community. There is no other protocol having that feature or attribute called community. Now, the next thing what we need to learn is whenever you have BGP, MPLS layer 3 VPN, you will always have DRS. I repeat, whenever you do MPLS layer 3 VPN using BGP, you will always have VRF. What is VRF? VRF is virtual route forwarding. VRF is a control plane which is created only for customer so that the customer routes won't get mixed up with the providers inside network. You see, between PE1 and PE2, there is a routing, right? We have OSPF or something, there is a routing. And there is a routing table. Now, if the customer routes get mixed with the same routing tables, then it would be very difficult for us to filter those customer routes and put it into VPN. I repeat, this is very important. We have a routing table already. In that routing table, if customer site A and site B routes get mixed up, what will happen? Then you cannot take the customer route and put it into VPN. So we need a separate control plane to control the customer traffic coming from site A and site B, and another control plane to take care of the ISP's network. You understand?
Right. Yes, I understand. Different routing table.
Let me Let me try to put it in another word. For all the traffic that is going to use VPN, I need another routing table.
Right.
For all the routes that need to be distributed through the VPN, I need another routing table because I am not going to distribute the provider route through VPN.
Right.
So whenever we have VPN, there will be always VRF. Did you get the answer why we need VRF whenever we have VPN?
Yes. To separate customer
Whenever
routes
we have,
from the provider route.
yeah, to have a separate control plane so that all those that are in the customer control plane will automatically enter into the VPN without any filtration.
Right.
You don't need to filter the customer out. You don't need to separate the customer out and the provider out. Next. We learned here that the routes are kept separate. Not only from the provider route, the customer routes are kept separate. If you have multiple customers connected to the same PE, we also need again another control plane for another customer, meaning we need separate control planes for each customer as well as for the provider. So if I have 5 customers, how many routing tables we need? 6. 5 plus the default routing table.
Right.
Yep. So we have to create VRFs whenever you have VPN. And how many VRFs? It depends on how many customers you have. For each customer, you want to have separate control over the route distribution. So we need to have multiple VRFs. More customers, more VRFs. Now, what does VRF represent? I told you more customer, more VRF. Now I'm asking the question, what does a VRF represent? A customer. Do you agree?
Yes.
A VRF represents a customer. So there is a need for an ID to identify that this VRF is of this customer. So whenever you configure VRF, we give a name. Okay, we put the command IP VRF cust P.
Right.
IP VRF cust P. Now this cust A and cust P cannot be used as the identifier to identify the customer. We cannot use this name. This name is just for you to keep this configuration separate.
Right.
This name cannot be used as the internal routing table identifier. This name can be used for you and me to understand for which customer the VRF is created.
Right.
So in order to identify the routing table of each customer separately, we use something called RD value. RD value is actually 64-bit. You will have a 32-bit value colon 32-bit value. So RD is route distinguisher. If I give a route distinguisher like 1:1, I should not use the same route distinguisher value for another customer. I can use this 1:2.
Right.
But I should not use the same number 1:1 for another customer on the same router. What does that mean? I can have the same route distinguisher for another customer on another router. Did you get the point? I repeat, route distinguisher should not be same for different customer on the same router. Right. It can be same for different customer on different P routers. Right. Route distinguishers are local to the customer. The route distinguishers are prepended with the customer's route. For example, you see, this alpha is advertising a network, let's say 10.0.0.0. And this beta is advertising a network, let's say 20.0.0.0. You know how they are identified? Alpha will be seen like this. Alpha will be seen like this. Alpha network is seen like 1:1 10.0.0.0. Whereas the one which is coming from beta will be seen as 1:2 20.0.0.0. So according to the control plane of layer 3 VPN, one subnet is not 32-bit. One subnet is
64. No, 96. Because 32 plus 32 plus 32. Yes.
Yeah. So each subnet is 96 bit length. Always the route distinguisher is prepended.
Right.
Now, we just learned what is route distinguisher. This is to tell the router, tell the local router that these two networks are not from same customer, is coming from different customers. Right. But how do we know that? In the VPN, see, for both the customers, the routes are going in the same VPN. How do we know which update is for which customer on the remote side? On the remote side, if I have two customers, customer B and customer A, okay, this is B. Okay, customer G. How do I know the update is for customer B and how do I know it's for customer A, G? How it knows? It is using the route target. Route target helps to identify the target to whom the update needs to be delivered. You understand?
Yes.
If I have two customers on this router, to know whether it is coming from side B or side G, you need a route distinguisher. Yeah?
Yes.
But to deliver to whom is being determined by
route target.
Route target is also 64-bit. Route target is the community value.
It's a route target.
With that community,
route target is
the community value. Okay. Community value. You see, BGP needs a value not to identify and deliver to the remote. You remember in the previous class, the lab when we did, the router 4 was attaching a tag called community value, isn't it?
Yes.
Now, when router 2 receives the update and it looks for the tag, when the tag matched, it assigned local preference of 400, isn't it?
Right, yes.
Likewise, here, this guy is going to export with a value called route target. Let's say he's exporting like 11:11. Now, wherever the same community value is mentioned as import, there the updates get downloaded. You understand?
Yes.
Export and import. how it is using the community of BGP. Likewise, if you export here with 22 as 22 and 22 as a community value, whoever wants to download it, they need to use what?
Import.
Import 22:20. To them, BGP will come and deliver it. You understood the community? This is what important part of MPLS layer 3 VPN in the theory. Practical, everything is important, but in the theory, this is where people are not clear. They are not clear with this route target and route distribution. Especially with the route target, they are not clear. And they are not clear with how the BGP community is involved. This is how the BGP community is involved. The import and export value is used as the community value for BGP to deliver. Right? All these things I'm going to do in action in our next class by taking a simple topology, same like what you see in our screen now. I'm going to take similar topology, and I'm going to explain all these things.
Why don't we just build a topology now, so when tomorrow morning come, we can just go straight. I have time.
Okay.
Just
no problem. Burning. Let me check what is burning. Vinod, இங்க இருக்காதீங்க. இதுல பேட்டரி நீங்க இதுல போட்டுருக்கீங்க. இது ஸ்மெல் வருது. Okay. So, as usual, let's take 1034 0.0/16. And all the routers should have loopback interface. At least router 3 and 6 should have loopbacking. It's very important for the control plane to match. I'll explain you in detail in the next class. When you check the routing table of the provider, this router 4 and router 5 will not have any route information about this 192. But still you will be able to ping if the VPN is successfully established between router 3 and router 6. What all needed? BGP is needed. Before that, what is needed? OSPF or ISIs is needed. And MPLS is needed. After which, we need VRF on PE routers. That's all. Right? So with the BGP, we'll have two sessions. One is normal IBGP.
right.
Another one is VPN P4. So BGP, yeah. First OSPF and MPLS, and then BGP with the two sessions. One is IBGP, another one is VPN P4. Oh, that's it.
No,
Any question? All right, so this is the file name MPLS-L3-VPN, which we will do this in the next class.